So mutually exclusive, again, is just talking about whether or not there's an overlap in the data. All right. Data sets can be let me get the right pen going here. The events contained within the sample space can occur at the same time if there is overlap. All right. So mutually exclusive, we're talking about overlap, and we're talking about this crappy pen. Pen's actually wonderful. It's just this interface overlap. All right. So I just look at my sample space and I would ask myself, all right, do I have any sevens that are also kings? I do not. All right. Oh, and just so you know, I may or may not have said this before. I apologize if I didn't. On the test, it's not a test of your knowledge of a deck of cards. So if there are card-related questions, then I will give you the sample space for a deck of cards. All right. Or maybe just a subset of the relevant part of the deck. All right. So you don't have to worry about memorizing this. So that it's not mutually exclusive.
Wait a second.
I'm sorry, it is.
Back when you guys all you kind of have a little note here. You will need to have these memorized.
Oh, so get rid of that.
Okay. So that's okay.
There was something on there that you'd need to have memorized, but not the deck of cards.
So don't bother memorizing the prime numbers and all that.
Oh, prime numbers you need to know.
Okay.
Yeah, that might have been what I was talking about. So I'll go back in a second and get a little bit more specific with that. Mutually exclusive. I almost said not mutually exclusive, but it is mutually exclusive. All right, because they're excluding one another mutually. All right, so that's our license to say I just take the probability of getting a 7, which is 4 out of 52. And I take the probability of getting a king, also 4 out of 52. And that's going to give me 8 out of 52. All right. So not bad in terms of the computation. Probability is never going to be difficult in terms of the math that you have to do. The only thing that makes probability difficult is knowing what math you need to do, right? Knowing what numbers I need to add, not actually adding them. But let me go back to that sample space really quickly, that sample space page, and see what the heck I was talking about. Yeah, that's old school. So that's garbage. The only things that you need to actually know would be dice. One coin, one die. And the primes. Now you don't have to memorize the set, but you do need to know what a prime number is and how to determine if a number is prime, because you can see in the second example that we're going to do, we immediately start dealing with prime numbers. And that's any number that's greater than 1 that's divisible by only 1 in itself. You can bring an index card again. So memorize as a loose definition. All right, so.
So the 6 said we can memorize up to the number 52 because we don't plan on going past that.
Right, yeah. Okay. Exactly. That is divisible by only 1 n itself. Like can be divided by.
Because that's going on my
Yeah, I mean, it's definitely valid because, when you have a little index card to work with, you kind of want to know what what you need to put on there and what you don't. And I wouldn't, I mean, I would feel terrible if I saw people coming in with index cards and one side of it had just the sample space of a deck of cards on it. You know, and be like, well, that's a waste of your index card. And then you see on the test that I gave you a printout of it, you'd be like, well, I hate you, dude. You know, so.
And sample test number 2 on the website, you know, the practice test?
I hope so. I'm pretty sure it is.
If we don't see one, can we email you?
Absolutely. And I'll
There is.
there is? Okay,
I
cool.
printed already.
I had every intention of putting it up, so it looks like I did. The hope is that I do that. Oh, we're on the next one. All right, so in the second question, it says for us to find the probability of getting a 7 or a prime. All right, so, well, looking at the deck of cards, we would want to be thinking about whether or not the prime numbers would exist within the deck. All right, so I'll just put a small list of the relevant primes. So 2, 3, 5, and 7. All right, those are the only primes that coincide with the deck of cards. Because even though the aces are all equal to one another, they don't have a number value. Same thing with the jacks, queens, and kings. All right, so you'll notice that 7 made its way into the list of primes. So that means that there is overlap. You could have a card that is both 7 and prime at the same time. So I have to take note of that. So this is going to be not mutually exclusive. Oh, jeez. So not mutually exclusive because there's some overlap. And so I'd use the lengthier formula. But you could also do it with a little, I'll call it number sense. Really, it's just a matter of just going through and counting up all the values that would satisfy the question. But if you're following the formula, it would be probability of 7 plus the probability of prime minus the probability that a card is 7 and prime at the same time, which rhymes.
7 is an and.
That's an and, yeah. Ampersand.
Dash PR, right? After and.
After and, it's just PR, yeah. All right, so probability of 7, we know is 4 out of 52. Probability of a prime number, well, here it looks like there's 4 of them, but you got to remember there's going to be 16, there's 4 per suit, right? For the clubs, the diamonds, the hearts, and the spades, so there's going to be a total of 16 primes in the deck. Now the ones that are both 7 and prime at the same time, those will just be all the 7s. So it turns out that I'm double counting the 7s when I count up all of the 7s and all of the primes, so I just have to subtract them off. All right, so if I just did a rote calculation, I don't know why that straight mark came up, but I think it's going to be too much of a pain to delete it. If I were to just count up all the 7s or primes, I would just go through and I'd say, okay, I got 2, 3, 5, 7, 2, 3, 5, 7, 2, 3, so a total of 16 of them. I wouldn't then count up the sevens because I would have intuitively said, well, I already got the sevens. So I would have got my 16 out of 52 that way, right? But what's happening here is I'm saying, all right, I'll take all my sevens, each one of those sevens, make note of those. Then I'll take all my primes. All right, 2, 3, 5, 7, 2, 3, 5, 7, 2, 3, 5, 7. It's kind of like you're mindlessly going through the process of counting without taking note of what you're counting, right? So when you go through the process, maybe it just doesn't click. Oh, wait a minute, I've already counted the sevens, so why would I count them again? Right? So this part of the process is removing that double count, right? So do you have to use the formula for something like this? Well, if you have the sample space, absolutely not, right? If it's listed for you out, you don't have to do it, but if it's not, then maybe you want to consider using the formula. So I show it both ways. A little something for everyone.
Can you just explain one more time why you highlighted 5?
Oh, that's a stray mark that the palm of my hand produced, and I know that if I try to delete that,
Okay.
I'm just gonna just disregard it. I'm gonna spend more time trying to delete it than I am gonna,
So it's nothing to
so
highlight.
nothing to highlight. Just, in fact, maybe I'll just highlight the whole number. Now I'm gonna highlight all the answers. Oh, okay, the answers are highlighted. So the next one says prime or even. All right, so prime or even is going to involve an overlap because I have the list of my primes here, and I can see one of them is an even number. All right, so it's not going to be mutually exclusive, so I'll make a note of that. Now, in most cases, you're making the note of that, mutually exclusive or not, for yourself. I just want to kind of give myself a reminder of what I'm really looking for. All right, so that means that there's going to be a subtraction component if I use the formula. So probability of prime plus the probability of even minus the probability of prime and even. So from the last problem, we learned that probability of getting a prime number is 16 out of 52. Getting an even, the probability of getting an even card, you could just count them up in your mind, or you can go back to the sample space. Either way, you're coming up with 2, 4, 6, 8, and 10 4 times, which is 20. And so I'm looking for prime and even. The only way that that happens is the number 2, which occurs 4 times. So these are the 2s. So 2 of hearts, diamonds, 2 of clubs, oh boy, 2 of spades. So a total of 4 of them. All right, so we get 32 out of 52. Oh, the number 20 is just the evens. So we're looking at, in the deck of cards, you're just counting up all the even numbers. So I have the 2, 4, 6, 8, and 10. That's a total of 5. But then we have 4 suits.
5 times 4.
5 times 4. Now 7 or not red. Well, in a deck of cards, yeah, this doesn't work out in every game of chance, but for cards it does. If it's not red, it's black. So this is really the same as saying probability of 7 or black. All right, which we know is not going to be mutually exclusive. And we know that because you could have cards that are 7 and black at the same time. So probability of 7 plus the probability of black minus the probability of 7 and black. All right, so 4 out of 52 for the 7s. Black, well, half the deck is black. So 26 out of 52. And 2 of the 7s are black. That would be the spades and the clubs. So we have to account for those. So that's 7 of spades, 7 of clubs. All right, so combine it all together and we're looking at 28 out of 52. Now we did an example last time that ended up being the same probability, except the question was 7 or red. So 7 or red and 7 or black ended up being the same answer, and that's because it's really the same question. It has the same characteristics. There are the same number of black cards in the deck and the same number of 7s that are black as there are reds. So it makes sense that they should come out to be the same probability. It's kind of weird because it's very mathy in the look of the work, when really, if you think about it, you could just go through the sample space and just count. But this gives you a more universal approach, so that if you're tackling a question that's not necessarily related to cards, you at least have a fighting chance, right? And so that's what it's all about. A fighting chance, a puncher's chance.